નમસ્તે મિત્રો, મારું નામ પ્રોફેસર ગિરીશ સી પંચાલ. હું વિશ્વકર્મા સરકારી ઇજનેરી કોલેજ ચાંદખેડા ખાતે સહાયક પ્રાધ્યાપક ગણિતશાસ્ત્ર વિષય તરીકે ફરજ બજાવું છું. મિત્રો, આપણે અહીંયા જીટીયુ ખાતે બી સેમેસ્ટર 3માં ચાલતો અભ્યાસક્રમ પ્રોબેબિલિટી અને સ્ટેટિસ્ટિક્સ એનો અભ્યાસ કરી રહ્યા છીએ, જેમાં યુનિટ 2 જે છે એ સમ સ્પેશિયલ ટાઈપ ઓફ પ્રોબેબિલિટી ડિસ્ટ્રીબ્યુશન છે અને એમાં આપણે અત્યાર સુધીમાં કુલ 1 થી 7 સેશનમાં અલગ અલગ પ્રકારના સંભાવના વિતરણો એટલે કે પ્રોબેબિલિટી ડિસ્ટ્રીબ્યુશન્સ જોઈ ગયા છે. આ અગાઉ આપણે સેશન 1 થી 5માં 2 પ્રકારના ડિસ્ક્રીટ ટાઈપના પ્રોબેબિલિટી ડિસ્ટ્રીબ્યુશન જોયા છે, જે છે પોઈઝન ડિસ્ટ્રીબ્યુશન અને બાયનોમિયલ ડિસ્ટ્રીબ્યુશન. ત્યારબાદ છેલ્લા 2 લેક્ચરમાં આપણે નોર્મલ ડિસ્ટ્રીબ્યુશનનો અભ્યાસ કર્યો, જેમાં સેશન 6માં આપણે નોર્મલ ડિસ્ટ્રીબ્યુશન વિશે જાણકારી મેળવી અને સેશન 7માં જે છેલ્લું સેશન હતું એમાં આપણે સ્ટાન્ડર્ડ નોર્મલ ડિસ્ટ્રીબ્યુશન્સની વાત કરી. તો આ બંને વચ્ચેનો ભેદ શું છે એ આજે સહેજ રિવાઇઝ કરી અને એના લગતે થોડાક એક્ઝામ્પલ્સ આજે ગણીશું. તો ચાલો આપણે શરૂ કરીએ આજનું સેશન. તો મિત્રો, આજનું આપણું લેક્ચર 8 છે એ નોર્મલ ડિસ્ટ્રીબ્યુશન ઉપર જ છે. સો આ અગાઉ આપણે નોર્મલ ડિસ્ટ્રીબ્યુશનનો જે અભ્યાસ કર્યો છે એમાં શું શું જોયું છે એનો સહેજ રિવાઇઝ કરી લઈએ, ત્યારબાદ આપણે આજનું સેશન શરૂ કરીએ. સો સૌ પ્રથમ મિત્રો, આજે નોર્મલ ડિસ્ટ્રીબ્યુશન જે છે એમાં જે રેન્ડમ વેરિયેબલ એક્સ છે એ કન્ટિન્યુઅસ ટાઈપનું છે, એટલા માટે આ નોર્મલ ડિસ્ટ્રીબ્યુશન પણ કન્ટિન્યુઅસ નોર્મલ ડિસ્ટ્રીબ્યુશન કહેવાય છે. સો ઇટ ઇઝ કન્ટિન્યુઅસ રેન્ડમ વેરિયેબલ. અને એના માટે જે પીડીએફ છે, પ્રોબેબિલિટી ડેન્સિટી ફંક્શન, પીડીએફ હતું એ એફએક્સ ઇક્વલ ટુ 1 સિગ્મા અંડર રૂટ 2 પાઈ e to the power minus 1/2 x minus mu divided by sigma whole square, જ્યાં xની વેલ્યુ જે હતી એ -ઇન્ફિનિટી થી ઇન્ફિનિટી સુધી. અને આપણે જ્યારે આ નોર્મલ ડિસ્ટ્રીબ્યુશનનો અભ્યાસ કરીએ છીએ ત્યારે આપણે જાણીએ છીએ કે એનું જે ગ્રાફ છે અથવા તો એનો જે સંભાવના વિતરણનો જે વક્ર છે, જેને આપણે નોર્મલ કર્વ કહી શકાય, એમાં સેન્ટરમાં મ્યુ હોય છે અને એની અંદર જે ઘેરાતો પ્રદેશ છે એ પ્રોબેબિલિટી બતાવે છે. સો ટોટલ પ્રોબેબિલિટી ફ્રોમ -ઇન્ફિનિટી ટુ ઇન્ફિનિટી આપણે વાત કરીએ સો એ પ્રોબેબિલિટી 1 થાય છે. અને જે આ પીડીએફનો એક ગુણધર્મ છે કે ઇન્ટિગ્રેશન -ઇન્ફિનિટી ટુ ઇન્ફિનિટી એફએક્સ બરાબર 1 થાય, એટલે કે આ જે એરિયા બને છે એ એરિયા આ વક્રથી ઘેરાતો જે પ્રદેશ છે એનો એરિયા 1 થશે. ત્યારબાદ આપણે સ્ટાન્ડર્ડ નોર્મલ ડિસ્ટ્રીબ્યુશનનો અભ્યાસ કરેલો. તો સ્ટાન્ડર્ડ નોર્મલ ડિસ્ટ્રીબ્યુશનને આપણે કરીશું પ્રમાણ્ય વિતરણ. તો આ જે સંભાવના વિતરણ છે એ સ્ટાન્ડર્ડ નોર્મલ ડિસ્ટ્રીબ્યુશન કેમ કહીએ છીએ? કારણ કે અહીંયા જે પીડીએફ છે ઉપર એમાં સિગ્મા અને મ્યુ આ બંને પેરામીટર્સ હતા, જ્યારે અહીંયા આગળ સ્ટાન્ડર્ડ નોર્મલ ડિસ્ટ્રીબ્યુશનમાં આપણે એક્સ માઇનસ મ્યુ અપોન સિગ્મા, એટલે કે જો રેન્ડમ વેરિયેબલ કેપિટલ એક્સ લઈએ અને આના બરાબર જો આપણે નવો વેરિયેબલ ઝેડ લઈએ છીએ તો આ ઝેડ જે છે એને આપણે સ્ટાન્ડર્ડ નોર્મલ રેન્ડમ વેરિયેબલ અથવા તો સ્ટાન્ડર્ડ નોર્મલ વેરિયેટ કહી શકાય. અને જો આ સિમ્પ્લિફાય કરવામાં આવે તો અહીંયા નવું ફંક્શન આપણું એ કયા ફોર્મમાં થતું હતું એ આપ જાણો છો, 1/√2 પાઈ e to the power minus z²/2. અને અહીંયા ઝેડની વેલ્યુ પણ -ઇન્ફિનિટી થી ઇન્ફિનિટી વચ્ચે હોય છે. અને આ જે નોર્મલ કર્વ આપણને મળે છે, જેને આપણે સ્ટાન્ડર્ડ નોર્મલ કર્વ તરીકે ઓળખીએ, અને જો એની વાત કરીએ તો એનો જે નોર્મલ કર્વ છે એ પણ સેમ આકાર ધરાવે છે, એટલે કે ઘંટાકર્ણ જે આકાર છે બેલ શેપ્ડ. પરંતુ જ્યાં ઉપર એક્સમાં મ્યુ હતું સેન્ટરમાં, અહીંયા આગળ ઝેડ બરાબર 0 છે, એટલે કે જો ઝેડની વાત કરીએ તો એ -ઇન્ફિનિટી થી ઇન્ફિનિટીમાં જ રન કરે. અને જે આ પ્રોબેબિલિટી બતાવે છે આ કર્વ, તો એની લેફ્ટ સાઈડ એ -1 -2 એ રીતે આપણે નંબર ફોર્મમાં કહી શકીએ, 1 2. જ્યારે જો એક્સ લેતા હતા તો અહીંયા આગળ म्यू हतुं अने अहींया आगळ धारो के म्यू प्लस सिग्मा, म्यू प्लस 2 सिग्मा एवा पॉइंट्स हता। लेफ्ट साइड म्यू माइनस सिग्मा, म्यू माइनस 2 सिग्मा ए प्रकारना पॉइंट्स हता अने आनी वच्चे जे घेरातो प्रदेश छे एनी पण आपणे चर्चा करेली। हवे आ जे नॉर्मल डिस्ट्रीब्यूशन छे, जे स्टैंडर्ड नॉर्मल डिस्ट्रीब्यूशन कहीशुं, एमां आपणे Z टेबल नी बात करी। Z टेबल शुं छे? तो Z टेबल आपणे जोई गया एम तो आ छे स्टैंडर्ड नॉर्मल टेबल, जेने आपणे Z टेबल तरीके पण ओळखीए छीए अने अहींया ए एरिया बिटवीन 0 टू Z एटले के प्रोबेबिलिटी बिटवीन 0 टू सम Z बतावे छे। आ Z ए आपेलो होय अहींया तो आ जे एरिया अहींया बतावे छे ए एरिया शोधवा माटे आपणे आ टेबलनो उपयोग करीए। तो दाखला तरीके शुं करता हता, 0 लेस थेन Z लेस थेन 1.23 आ प्रकारनो आपणे जो प्रोबेबिलिटी फाइंड करवी होय एटले के अहींया 1.23 होय अने 0 होय तो आ जे शेडेड एरिया छे ए फाइंड करवो होय तो आ टेबलनी मददथी आपणे आ 1.23 मां 1.2 आपणने अहींया वर्टिकल कॉलम्समां देखाशे तो 1.2 अहींया जोई शकाय छे, अहींया छे अने त्यारबाद एमां आपणे 0.03 एड करीए तो 1.23 बने छे। 0.03 वाળી कॉलम अहींया छे। सो आ बंनेने अहींया आपणे इंटरसेक्शनमां जोईए तो आपणने मळे छे 0.3907 एटले के आ जे प्रोबेबिलिटी हती ए प्रोबेबिलिटी हशे 0.3907। सो आ रीते मित्रों आपणे Z टेबलनो पण अभ्यास करेलो। तो हवे आगळ जोईए, आजनो आपणो जे विषय छे नॉर्मल डिस्ट्रीब्यूशनमां हजू आगळ केटलाक वधु एक्जाम्पल जोवानो छे। तो एक्जाम्पलथी शरूआत करीए। सपोज आपणे एवुं आपेलुं छे कि इफ x इज अ नॉर्मल वेरिएट, जेने आपणे प्रमाण्य चल तरीके ओळखीए छीए, विथ मीन 30 and standard deviation 5. The question is find the probability that 26 less than or equal to x less than or equal to 40 and b x is greater than equal to 45. Suppose this is the problem and we have to find the probability. Here it is given that the distribution follows the normal distribution because x is given, x is normal variate. So here x is normal variate and given mean. So for x the mean is mu and that is expected value of x and that is given 30. Now standard deviation is sigma and sigma is 5. So value of mu and sigma are given and they are the parameters of the normal distribution. Now we take z equal to x minus mu divided by sigma because we have to convert our normal distribution to the standard normal distribution. For that this is the transformation. So just we put the value of mu and sigma, it is x minus 30 divided by 5. Now given A, we have to find probability of 26 less or equal to x less or equal to 40. So for that x equal to 26 and x equal to 40 we have to find z. So if x equal to 26, what is the value of z? Let us find. So from this we can say z equal to 26 minus 30 divided by 5, that is minus 4 by 5 and that is minus 0.8. Same way if x is equal to 40, then again we find z by putting x equal to 40 here. So, 40 minus 30 divided by 5, this is 10 divided by 5 and that is 2. So, actually the probability between 26 to 40 is nothing but the probability between minus 0.8 less or equal to z less or equal to 2. So, this is now converted into standard normal distribution. So, we now find it. So, first of all let us see the graph. So, normal curve if you observe, then where are the points? Let us see, say this is normal curve for z. So, this is say minus 0.8 and this is 2. So, this area we have to find, this shaded area, and this shaded area is made by the two portions. The first is from minus 0.8 to 0 and the second portion is 0 to 2. So, that we have to divide into two parts. So, we can write this is as minus 0.8 less than z less than 0 plus probability between 0 to 2. Now, this one, if you observe, this is from left side, same way suppose we take 0.8 here. So, this area is similar. So, 0 to 0.8. So, we can replace this by probability between 0 to 0.8. This is as it is, probability from 0 to 2. Now, we have to find these two values. We know for this we have to use the z table. So, from the z table we have to find the values. So, first is 0.8. So, let us see where is 0.8. So, 0.8 is here, you can see, and it is just 0.7. So, in the first column no addition, so 0, and so this is the probability 0.2881. So, here the first value is 0.2881 plus next is probability between 0 to 2. So, we have to take 2 from the normal table. So, 2 is here and this is the first column. So, 0.4772. So, we have to put 0.4772. Now, taking the addition of these two, we will get 0.7653. So, this is what the probability we want to find, probability between 26 and 40. The next one is to find probability x greater than equal to 45, that is our question. So, we have to find it. For we have to take z equal to x minus 30 divided by 5 and we have to find this for x equal to 45. So, we put x equal to 45 here. So, 45 minus 30 divided by 5 and that is 15 divided by 5 and that is 3. So, for x equal to 45 we will get z equal to 3 and therefore, we can have probability x greater than equal to 45 is equal to probability of z greater than equal to 3. So, what is that? Let us see in the normal curve, then and then we can realize it, how to find the probability. So, you see z is greater than 3. So, suppose 3 is somewhere here and z is greater than 3. So, what is the probability? This is the probability 3 to infinity. So, how to find it? So, if we find the probability from 0 to infinity and then we take the subtraction from the probability, subtraction of probability from 0 to 3. So, what is that? This is probability 0 to z to infinity minus probability from 0 to 3. Okay. So, this is the half probability of the total probability 1 and so this value is always 0.5. So, this is 0.5 minus probability between 0 to 3. Now, this probability we can find from the normal table. So, for 3 what is that? Let us see. For 3 the probability is 0.4987. So, here we will put 0.4987 and the subtraction will give you 0.0013. So, this is the probability what we want, the probability for x greater than or equal to 45. Now, one more example. If x is normally distributed random variable with a mean 2 and standard deviation 0.1. Now, our question is to find probability of mod of x minus 2 greater than or equal to 0.01. So, let us see how to find it. So, first of all our question is to find the probability for the normal distributed random variable. So, here given x is normal random variable with mean mu is equal to 2 and standard deviation sigma is equal to 0.1. So, these two data are given to us and by the two data we can have the normal distribution. Now, we have to find probability of x minus 2 greater than or equal to 0.01. So, if we add here probability of x minus 2 less than 0.01, then you can see they are complements of each other and total probability is 1. So, if we have this one, we can write probability of mod x minus 2 greater than or equal to 0.01 equal to 1 minus probability of mod of x minus 2 less than 0.01. So, here if we find it, then we can have the answer. So, what is that? Mod of x minus 2. So, here we simplify that mod of x minus 2 less than 0.01, that implies you can see this is 0.01 negative and x minus 2 less than 0.01 positive and adding 2 on both sides. So, 2 minus 0.01 less than x less than 2 plus 0.01 and left side you will get 1.99 less than x less than 2.01. So, this one can be replaced by this one. So, right side we will have 1 minus probability of 1.99 less than x less than 2.01. So, that probability we have to find. Now, for that we have to introduce normal standard variate. So, that is z equal to x minus mu divided by sigma. Now, mu is given, the value of mu is given to sigma is 0.1 and therefore, x equal to 1.99. What is z? So, z equal to 1.99 minus 2 divided by 0.1 and if we simplify, the numerator is minus 0.01 and divide by 0.1. So, minus 0.01 upon 0.1 and that is minus 0.1. So, this is for x equal to 1.99. Same way, if x equal to 2.01, then z is equal to 2.01 minus 2 divided by 0.1 and that is 0.1. So, 1.99 is related to the z equal to minus 0.1 and 2.01 is related to z equal to 0.1. So, from the star our probability that mod of x minus 2 greater than equal to 0.01, that is equal to 1 minus probability. This equation we convert into z form, and so here we can say minus 0.1 less than z less than 0.1. So, we have to find this probability. Now, let us see the normal curve, and we consider this is 0, this is 0.1 and say this is minus 0.1. So, this probability is there. So, this is the shaded area. Now, this is symmetry. So, we can say 1 minus 2 times probability of 0 to 0.1. So, if we take this probability, then multiply by 2, we will get the total probability. Now, this probability we can find by using z table. So, 1 minus 2 into what is the value from 0 to 0.1. So, let us see the z table. We have to find the value for 0.1. 0.1 is here and this is 0.0398. So, the value is 0.0398 and that is 1 minus the multiplication will give you 0.0796 and subtraction will give you 0.9204. So, that is the required probability. Now, let us see one more problem. If x is normal variate with mean 120 and standard deviation 10, find C such that probability of x greater than C is 0.02 and probability of x less than C is 0.05. So, let us see what the problem says. So, first of all, x is given, which is normal random variable, that is normal variate with mean mu equal to 120 and standard deviation sigma equal to 10, and therefore, we define z a standard normal variate, that is x minus mu divided by sigma. So, x minus 120 divided by 10. Now, we have to find C, that means this C value we have to find and for which the probability is given. So, reverse problem. So, we have to use the z table in reverse form. So, first of all, let us take the first one to find probability of x greater than C equal to 0.02. So, to find C for which probability is given. So, how to find it? So, given that P x greater than C is 0.02. So, what it means? That gives you 1 minus probability of x less than or equal to C, because total probability is 1 and they are complement to each other. So, we can have this 1. Now, if we transform this x form into the standard form. So, my x is converted to z and C is converted to what? So, here we put x equal to C, then z is equal to C minus 120 divided by 10. So, here we have to put that value, and if we call it Z1 for a while. So, this is nothing but probability of Z less than Z1 on the left side. So, we have this one. Now, what is probability of Z less than Z1? So, that is 1 minus 0.02 and that is 0.98. So, if we see that this probability is greater than 0.5. So, what it means? So, let us see, suppose there is some Z for which this probability, and that is from minus infinity to Z1 and Z1 is somewhere here. Okay. So, where is the Z1 from these all points? So, since probability from minus infinity to Z1 is 0.98 and which is greater than 0.5, if your Z1 is left side of 0. So, the probability is always less than 0.5 and if the probability is greater than 0.5, then my Z1 must be on the right side of 0. So, Z1 is somewhere here. So, this probability is given actually. So, this is nothing but this probability. So, what can you say from this is greater than 0.5 and therefore, Z1 is greater than 0, which is on the right side, and therefore, we simplify this as follows, that we can write probability from minus infinity less than Z less than 0 plus probability from 0 less than Z less than Z1. So, two parts, this is the one part, this is the second part. So, we can write the left side as a sum of these two probabilities and right side is 0.98. Now, again we see here that this is the half of the probability and that is 0.5. So, first part is 0.5, second part we keep it as it is 0 to Z1 and that is 0.98, and therefore, what is probability between 0 to Z1? That is nothing but 0.98 minus 0.5 and that is 0.48. So, that we have obtained. Now, this one we can find from Z table. For this we have to use Z table, but what is given here? The probability is given, this probability is given. So, 0.48 we have to find in the normal table and this 0.48 is at what Z1, that we have to find. So, let us see, let us observe the normal table. So, 0.48 we have to find and 0.48, suppose you see. So, 0.48 is somewhere here, it is nearby this and this. So, 0.48 is somewhere in between these two numbers, but which one is very near to that? So, you can see 0.48 minus 0.4798. So, it will be lesser than 0.48 minus 0.4803. So, this is nearer than this one. So, this value we have to take 0.4798. So, 0.4798 is for what? So, this is for 2.0 and here we have to find the upper point and that next point is 0.05, and so we have to take here Z1 is equal to 2.05 because 2.0 plus 0.05, that is the value for which the probability is very near to 0.48. So, we can consider this Z1 as 2.05 and now what is Z1? We have already taken Z1 as C minus 120 divided by 10 and that is 2.05. So, let us simplify, C minus 120 is equal to 20.5 and therefore, C equal to 120 plus 20.5 and therefore, C is equal to 140.5. So, this is the value for which probability of x greater than c is 0.02. So, in this way we can find the value of c. Now, next problem, if the second part is there given probability of x less than c is 0.05. So, how to do it? Let us see. So, here we first of all convert this into z form. So, probability we can say probability from z less than some z1, and what is z1 here? So, for x equal to c, z equal to c minus 120 divided by 10, and therefore, we call it z1 here. So, that is given 0.05. Now, what can you say? This we see in the normal curve. So, z is less than z1 and the value of the probability is 0.05 and that is less than 0.5. So, what will be the area? So, that z1 point must be on the left side of 0, and then this probability is less than 0.5, and therefore, we can say z1 is less than 0, that means negative, and therefore, this probability can be given as probability from minus infinity to z to z1, that is 0.05, and this probability we can find in this way, say minus infinity to 0. So, probability from minus infinity to z to 0 minus this probability. So, from z1 to 0, and z1 to 0 will be given by the symmetry 0 to minus z1 here. So, probability from 0 to z less than minus z1, here minus z1 is positive, since z1 is negative, minus z1 is some positive number. So, that we can find, and that is given 0.05. Now, what is that? This is the half of the total probability, and that is 0.5 minus probability from 0 to minus z1, and that is 0.05, and therefore, probability from 0 to minus z1 is 0.5 minus 0.05, and that is 0.45. So, now we will find this z1 from the z table. So, z table will give you the probability 0.45 for what value of minus z1. So, 0.45 we have to get from the z table. So, let us see where is 0.45 in the z table. So, 0.45 is, you see, it is near to these two values, and this is 0.4495 and this is 0.4505. So, what we have to do? We have to take the middle value. So, which one is the middle value? So, which is very near to 1.6, you see both are in the 1.6. So, for the first one this is 1.6 plus what? So, this is 0, 1, 2, 3, 4. So, that is nothing but 1.64, and second value is for 1.65, and we have to take the average of these two. So, this plus this divided by 2, and that is the correct value of z1. So, let us calculate it. So, here we have z1, that is minus z1, okay, here. So, minus z1 is nothing but 1.64 plus 1.65 divided by 2, because for both of them our value 0.45 exactly in between, it is not very near to the first one. and it is not very near to the second one. So, it is exactly in the middle, that is why we have to take the mean of these two numbers, and that is nothing but 1.645. So, this is the value of minus z 1, and therefore, z 1 is 1.645, but negative number, and z 1, put the value of z 1, this is c minus 120 divided by 10, this is minus 1.645, c minus 120 is equal to, you multiply by 10, this is minus 16.45, and then c is 120 minus 16.45, and that is nothing but 103.55, and this is for which. So, probability of x less than c is 0.05. So, this is the value of c for which the probability is 0.05. So, in this way we can use the z table in the reverse form. Now, let us see one more example, but before that we see expected frequency. તેને કહીએ અપેક્ષિત આવૃત્તિ of random variable x for normal distribution. So, અપેક્ષિત આવૃત્તિ કોને કહીશું? So, for normal random variable x, expected frequency is given for a less or equal to x less or equal to b is equal to n into the probability between a to b. Okay. So, for what number of items the probability is between a to b, that number we can find. So, here n is total frequency of x. Now, let us see this expected frequency and understand it with some example. So, the example is, in an exam of 500 students, the average marks and standard deviation of marks are given, and they are 52 and 8 respectively. Now, the marks obtained follow the normal distribution that is given to you. Find the number of students, number 1, who secure more than 60 marks. Number 2, find the number of students who secure marks between 48 and 56. And number 3, students who failed in the exam. Here given, if the minimum passing marks is 36. So, these three answers we have to give. So, exam is there and score here it follows the random variable that is also given. So, we call x as the random variable and x is the marks obtained by the students, that is the random variable, and it is normal random variable because we are given that it follows the normal distribution. Now, here the mean mu is given, that is 52, and standard deviation sigma, that is given 8. So, this information is given to us, and now we have to find the answer of these three questions. So, first of all what we have to do, we introduce standard normal variate z, that is x minus mu divided by sigma, x minus 52 divided by 8. So, first problem is to find the number of students getting more than 60 marks. So, for that we first of all find probability of x greater than 60. So, here we say if x equal to 60, what is z? So, z is equal to 60 minus 52 divided by 8, 60 minus 52, that is 8 divided by 8, and that is 1. So, we can say this is nothing but probability of z is greater than 1. Now, how to find this probability? So, let us see the normal curve, this is 0 and this is for z, and we have to find probability of z greater than 1. So, say 1 is here and this is the probability. So, how to find the probability? So, we can write this is probability from 0 to infinity minus probability from 0 to 1. So, this is the 0 to infinity probability, and we can take subtraction of this probability. The half probability is 0.5 minus, and probability between 0 to 1 we can find from the z table. So, here 1 is there. So, for 1 you see this is 1, and from the first column you can get 0.3413. So, 0.3413, and the subtraction will give you 0.1587. So, what is that? This is the probability for what? So, probability of x greater than 60 is 0.1587, and this is the probability of students getting marks more than 60. And now, what we want? We want number of such students. So, number of students getting marks more than 60 is equal to n into the probability of x greater than 60. Now, what is n? So, how many total students are there giving exam? So, there are 500 students giving the exam into the probability. What we want is 0.1587, and what is that multiplication? This is nothing but 79.35, and so from that how many number of students? So, there are 79. Here we can approximate this by 79. So, there are 79 such students who gets marks greater than 60. Now, second problem in the similar way, here we find probability between 48 to 56. So, marks obtained by the students is between 48 to 56. So, first of all we have to write the Z form. So, x equal to 48 will give you Z equal to 48 minus 52 divided by 8, and that is minus 4 by 8, that is minus 0.5. Same way x equal to 56, that will give you Z equal to 56 minus 52 divided by 8. So, that is 4 upon 8, that is 0.5. So, similar way here we can write minus 0.5 less than Z less than 0.5, and that is nothing but 2 times probability between 0 to 0.5, and this probability we can find from the table, and the Z table will give you, we have to find the probability for 0.5. So, let us see 0.5, the probability is 0.1915. So, here it is 0.1915, and the multiplication by 2 will give you 0.3830. So, this is the probability of students getting marks between 48 and 56, and therefore, number of students getting marks between 48 and 56 is equal to n into the probability of 48 less than x less than 56. Now, n is 500, that is given, and the probability we have just found 0.3830, and that multiplication you have to do, and that is 191.5. So, approximately you will have 191 students. So, there are 191 such students. So, means there are 191 students who are securing marks between 48 to 56. Third one is students who failed. So, passing minimum marks is given, that is 36, and therefore, first of all we have to find how many students are failed, and so for that we need to find the probability of the students who are failed. So, who are securing marks less than 36. So, that we have to find. So, in Z form, first of all if we take x equal to 36. So, what is Z? So, Z is 36 minus 52 divided by 8, and that is minus 16 divided by 8, and that is minus 2. So, now what we have to find here, this is nothing but probability of Z less than minus 2. Now, from the normal curve let us observe where is it. So, this is Z 0 and minus 2 is somewhere here. So, this is the probability of failed students. So, what is that? So, here we see this is from minus infinity to 0. So, we can write this is probability from minus infinity to Z to 0 minus this probability, okay, and this probability is from minus 2 to 0, and if we take 2 here. So, that is nothing but probability from 0 to 2. So, probability from 0 less than Z less than 2. So, the first one is the half probability, that is 0.5 here. So, this is 0.5 minus probability from 0 to 2. So, from the Z table we see for 2 that is given 0.4772. So, 0.4772, and the subtraction will give you 0.0228, and that is nothing but the probability of failed students. and therefore number of failed students is equal to n into the probability of failed students, that is probability of x less than 36. This is 500 multiplied by the probability 0.0228, and that is 11.40, and so equivalently we say 11 students. So, there are 11 failed students. So, they are expected number of students. Now, let us see a last example. So, a company produces registers with resistance of mu equal to 100 ohms and standard deviation sigma is equal to 2 ohms. Now, what percentage of resistors have resistance between 98 ohms and 102 ohms. So, this probability first of all we have to find. So, what is given? Let us see. Here we assume that x is the random variable that gives you resistance of resistors in ohms. Also given mu equal to mean, that is 100 ohm, and standard deviation sigma, that is 2 ohms. Now, we have to find the probability between 98 and 102 ohms. So, if x is 98, then what is z? So, z is 98 minus 100 divided by 2, that is minus 2 upon 2, it is minus 1. Similar way, if x is 102, then z is 102 minus 100 divided by 2, that is 2 upon 2, 1. So, in this way, here first of all we find probability of x between 98 and 102, and that is equivalently said as probability between minus 1 to 1 in standard normal variate. So, what is that? This is nothing but the probability between minus 1 to 1, and you see they are symmetric, and so we can say 2 times probability from 0 to 1. And from the normal table, earlier we have seen that the value is 0.3413 and the multiplication will give 0.6826. So, what is that? This is nothing but the probability. This is nothing but probability of resistors with resistance between 98 ohm and 102 ohms. Now, the percentage is 0.6826 multiplied by 100, and that is 68.26 percentage. So, this is the required percentage of resistors between the resistance 98 to 102 ohms. ओके. सो मित्रों, આજે આપણે એક્ઝામ્પલથી એને આપણે પૂરું કરીએ. તો મિત્રો, આજે આપણે જે નોર્મલ ડિસ્ટ્રીબ્યુશનનો અભ્યાસ કર્યો એમાં આપણે એના અલગ અલગ પ્રકારના કેટલાક એક્ઝામ્પલો જોયા. તો આ સાથે આપણે કુલ 3 સેશનમાં નોર્મલ ડિસ્ટ્રીબ્યુશનનો અભ્યાસ કરેલો. જ્યાં પ્રથમ સેશનમાં આપણે નોર્મલ ડિસ્ટ્રીબ્યુશન શું છે એની કેરેક્ટરિસ્ટિક, એના મીન, મીડિયન, મોડ વગેરેનો અભ્યાસ કર્યો. ત્યારબાદ સ્ટાન્ડર્ડ નોર્મલ વેરિએટ શું છે અને સ્ટાન્ડર્ડ નોર્મલ ડિસ્ટ્રીબ્યુશન શું છે એનો અભ્યાસ કર્યો અને આજે આપણે એના રિલેટેડ ઘણા બધા એક્ઝામ્પલ જોયા છે. તો આ સાથે આપણે નોર્મલ ડિસ્ટ્રીબ્યુશન અહીંયા પૂર્ણ કરીએ છીએ. હવે પછીના લેક્ચર્સમાં આપણે એક્સપોનેન્શિયલ ડિસ્ટ્રીબ્યુશન અને ગામા ડિસ્ટ્રીબ્યુશનનો અભ્યાસ કરશું. સો આ સાથે અહીંયા આપણે વિરામ આપીએ છીએ. જય ગુજરાત, જય હિન્દ.